Alright, today we're doing 8.3 using intercepts. Like we just talked about, we've been doing intercepts, talking about the x-intercept and the y-intercept all week. And I've been asking you, where does it cross the x? Where does it cross the y? That's exactly what we're talking about today. But now today I'm going to show you another way to graph these without doing t-charts. And what we're going to do is we're going to find the intercepts today by substituting 0 in for the x and finding what y equals, and then substituting 0 in for the y to see what x equals. So I kind of just gave you the answers here. To find the x-intercept of a line, substitute 0 for y in the line's equation and solve for what? And solve for x, because if you're putting 0 in for the y, we'd have to solve for x. So then you do, after you get that answer, you take the equation again, that same equation, and you put 0 in for x to find the y. You're going to love this because there's no rearranging today that we have to do. We just find the x, then we go back, we find the y, and we put them on the graph. It's a fun day in the land of Mrs. Lennon's mathematics. All right. Find the intercept of a graph. So here is our equation. Now, what we've been doing in the past, we'd have to rearrange that, pick 3 or 4 numbers, and then graph it using our t-chart. None of that at all today. Life, big old sunshine. Easier way today. To find the x-intercept, let y equals 0. All right? So in this first one right here, we take this equation, and where this y is, we put a 0 in for it. So this all stays the same. 2x minus 5 now times 0, because this is our equation, you draw your line down the equal sign, equals a negative 10. Well, that's why we always use 0 in our t-chart, because it made life so easy. What is negative 5 times 0? 0. So that just cancels all out. And leaves me with what? Woohoo! Now I'm down to 2x equals a negative 10. Divide both sides by, and what does x equal? A negative 5. So I know that x equals a negative 5. I'm halfway done. I found my x. Now, let's do the same thing again in the exact same equation, and now let's find the y. So now this time, instead of putting the 0 in for the y, we put it in for the x. So now, brilliant. 2 times 0 is 0, so that disappears. And leaves me with what? Negative 5y equals a negative 10, because this is my equation. Draw my line. Now what do I have to do to solve this? What do I have to do to solve this? 5? Divided by what?
5.
What kind of 5?
Wait, hold on. Wait, yeah, divided by negative 5.
Yeah, divided by negative 5.
I got 2 for an answer.
So, oh, you got the right answer though. Okay. Y equals, so a negative 10 divided by negative 5 is what, class?
2.
Positive 2. So now we have y equals 2. So we've got our x and we've got our y. Now we go to our graph. The x-intercept is, what did we get for x? A negative 5. So plot the point negative 5 and 0. Well, the x is negative 5. So from the origin, where do I go? Left or right? Up or down? Where do I go if my x equals a negative 5? Remember we graphed those easy ones? On the x-axis, x is a negative 5. Okay, and then down here we said y equaled 2. So that's the same as 0, comma 2. That's my y. So on the y, let's see, x, y, my y is 2. X, y, my x is negative 5. So where do I go from here? Up 2. Using your straight edge, not your free hand, using your straight edge. Now don't just connect. A lot of kids like to go like this and just connect the axes like that. Don't do that, okay? We're not making triangles. Go ahead, broaden your horizons here a little bit. Expand your horizons, I should say. Get that other line out. And extend that line through like that, instead of just connecting the axes to make it a triangle looking thing. Because this line goes on for infinity. That goes on and on, that equation. There. How easy was that? Raise your hands if you like that one better. Wow, everybody voted for that this morning. Amazing. Okay, here we go. Next one. Practice some more. So, does it matter which one I solve for first, the x or the y? No, you pick. Doesn't matter to me, because you have to do them both anyway. Skylar, which one should I do first? You get to pick today.
The x.
Okay, so you want me to put 0 in for x?
Yeah.
So what happens if I put 0 in for the x here?
So,
It disappears, doesn't it? So now I solve that. Because if I put 0 in for the beginning part, it cancels it out. Divide by 3. What does y equal? 2. So I know y equals 2. So now next to it, so on the next one now I want to solve for this one. So the same one, 2x plus 3y equals 6. Now I want to solve, if we solve for this one, now I'm going to put a 0 in for the y here, so that'll take away that. I divide both sides by, yep, 2. Now what does my x equal? 3. Easy schmeezy. So which one do you want to plot first? You want to plot the x first? All right, tell me where I go from the origin.
Right.
I go to the right 3. Does everybody agree? Is this where you want me to put a point? This is my x-axis, and you have a 3 on the x. Ooh, awesome. So then where do you want me to go for the origin for my y?
Up 2.
Up or down 2?
Up.
Up 2. Nice. Now get your straight edge. And again, don't just connect the axes and make a triangle. I don't want a right triangle. Extend it through your graph so it looks like that. Questions on that one? Okay, give you a couple seconds to come up for x and y for number 2. Raise your hand when you get an answer of x and y. Will you go up and solve one for me, please? Show me your work for either the x or the y. You pick which one you want to do. Oops, sorry, just grabbed this pen. Okay, she come up with y equals -2. Yay or nay?
Yay.
Good, everybody agrees? And what I liked here is she put the 0 in here, and she did not forget her negative sign. She divided by that -6. Sometimes we leave behind that negative, and then our graph is completely off. So everybody agrees we have the y at the -2. Will you pick somebody to plot that for you on the graph? The y equals the -2? Where would that go on our graph? Agree?
Yeah.
Alrighty. Hey, will you pick somebody to solve for x, please? X equals +4. Anybody disagree? All right, will you pick somebody to plot that for you? You're looking at that funny. Do you think you did something wrong? Ah, interesting. Thank you. So first she came up here and she put it up here, and then she stood back and looked at it like, wait a minute. Aha, and then she kind of smiled and went, oops, and erased it and went, oh, the x is a 4, so on the x-axis we have to be at the 4, not on the y. The y was the -2 on our y. So then with your straight edge, what kind of slope is this, positive or negative? Positive slope. All right, questions? Any questions? How many think this is like super ninja easy compared to the T-charts? Hey, yeah, I agree. That's why I teach you the hard way first, because then you really appreciate this way. All right, then there's word problems where we can set up, and I know you've seen problems like this when you do math testing. And these are the kind of problems that comedians make fun of on their shows. It's like, all right, you run and walk on a fitness trail that is 12 miles long. You can run 6 miles per hour and walk 3 miles per hour. Write and graph an equation. Can't you just see Jay Leno going off on a math question? You know, the train was going this far at this speed. It's really not that hard. So with what we just learned using both x and y in our equations, how can we use this to represent and find out what they're asking for? You run and walk on a fitness trail. The fitness trail is 12 miles long. What is in math? Equal. So is 12. Where do you suppose we're going to put the 12? Yes, behind the equal sign. It equals 12. This trail equals 12 miles. Is 12. Equals 12. You can run 6 miles per hour. So we know that we can run 6 miles per hour. We can walk 3 miles per hour. Write and graph an equation describing your possible running and walking times on a fitness trail. Give 3 possibilities of combinations of running and walking. Well, first of all, let's set up the rest of our equation. How fast can we run? We can run 6 miles per hour, right? Running time, 6 miles per hour. What's our walking time? 3 miles an hour. Well, do we know how many miles we run? Do we know that? No, so what should we give that? X. So let's make that our x. So now we have 6x added to our 3x again? No, because this is running. We can't use x for the walking because running got the x. So what are we going to give the walking? Sure, let's give it our y. equals 12. So now we have our equation. 6x plus 3y equals 12. I didn't want my answer showing. There we go. So let's find the x-intercept. All right, well, first of all, we have to write our equation. 6x plus 3y equals 12. I need to rewrite it again down here. 6x plus 3y equals 12. Now they want us to solve for what first? The x. So if I find x, what do I have to put in 0 for? Do I put in 0 for the x or the y if I want to find x? I put 0 in for the y, right? So that'll cross that out. So now I have 6x equals 12. Divide by 6. What does x equal? Positive or negative? So then go down here, find the y. So I have to put 0 in for the x. Divide both sides by 3. And what does y equal, class? Positive 4. Nice. So now let's graph it, which I think you already saw my answer for my graph. So now on our graph, this is your coordinate plane, but notice they just don't have it extended. See here? If you're to add those, there's your coordinate plane. What quadrant do we have? They show us what quadrant of our coordinate plane here. Nice. I'm seeing this. This is just the quadrant 1 of our coordinate plane. All right? So therefore, if x is 2, on our x-axis, then we find the 2. Put your dot there. On the y, we find our 4. And now in this situation, you do connect your axes because they only give you the one quadrant. So you connect your axes and you get this line right there. So give me some different situations along the way. We could run, what? How could we say that? What are some different situations, some points on that line that would make that equation work? We could, what? Run 2 hours, or excuse me, yeah. We could run 2 hours and not walk at all, and we'd get what? 12 miles. Or we could walk for 4 hours. Okay, so let me rewrite this. 6x plus 3y equals 12. If we walked, because this was our running, right? And this was our walking. So if we didn't run at all, how many hours would we have to walk? 4, because 3 times 4 is 12. If we didn't walk at all, how many hours would we have to run? 2, because 6 times 2 is 12. Is that where it's at? Look at that. What would this one be if we ended up right here on the line? What does that tell us? We'd have to do what and what? We'd have to run what? Run 1 hour? Well, let's see if this works. 6 times 1 plus, what's walking? 2? 3 times 2, does that equal 12? 6 times 1 is? Plus 6 equals 12. So yes, that would work also. That's another scenario we could use. So there's 3 different ways we could do that trail. We could run it, or we could just walk it, or we could do 1 hour of running and 2 hours of walking to get our 12 miles in. See how that line? And if you really wanted to get tricky, you could go in between here and do halvesies and half hours. Depends upon how detailed you want to get. But in that case, we're done. Questions? All right, your homework for today. Page 400. I want you to do 10 through 18. I will hand out graph paper because 10 through 18 you will have to do all of your homework in your notebook, all the solving for 0, 0, substituting your zeros in, and then you have to graph all these after you show all your work in your notebook. Numbers 42 through 48 are review. That will be in your notebook as well. All right, so I will hand out the graph paper for 10 through 18, and then you're also to do 42 through 48. This will be due Friday. Now, how many of you still have your page 4 to work on in your Friday packet? Okay, if you have time, if there's time left at the end of class, you can also work on your page 4 in your Friday packet or work ahead in there. So here's your graph paper. You have to have 2 each since there's 9 problems to graph. And make sure when you graph them on your graph paper that you number them so you know which graph goes to each problem. Okay, before we take our 5-minute break, I want to go over this problem quick though, because everybody looks at this one and it's so much easier than the ones that we did on our notes. So what do you get if we say we just have this equation? This is the first one in your homework. 5x plus y equals 5. Now, what happens if I put 0 in for the x? It cancels out, right? Well, now what? What do I have left? Y equals 5. All done. Yeah, it's that simple. So don't let it throw you off course. It is that simple. That's all you would end up getting is y equals 5. That's the first part of your number 10. All right? So that one is just super simple. All right, now we'll take our 5-minute break.